Good morning, everybody. Welcome back to another weekly daily broadcast of SAT Khan Academy problems being solved live. So we're going to continue with the next set of Khan Academy problems. We're moving on to the section on table data. And without further ado, let's get into it. Again, if you're watching on Instagram, make sure to jump onto my YouTube channel. Go to YouTube, search for Scalar Learning, and you can watch the actual live feed. See me solve the problems instead of just watching me talk about them. And that's it. All right, let's get to it. Let's jump onto the share screen. Happy Friday, everybody. Boom. Here's the section table data. Again, as always, I haven't seen these problems before. I'm seeing them for the first time with you. So we are all solving them together. Let me just minimize this. This thing keeps popping up in the middle. All right, there we go. It's much easier. So table data, this is going to be a little, I assume, data analysis, statistics type stuff. Now, they did mention, too, when I went to the recent talk from the College Board, that there's a much heavier emphasis on statistics and information like this. So this is quite good that we're doing this. All right, first question. We got this crazy table over here about reading. It says several English professors categorize the literacy works from their seminars by time period and length as shown in the table at the left. According to the table, what percentage of those books with 500 or more pages are from the 19th century? So let's see, what percentage of those books with 500 or more pages? Oh, man. All right, so here's the column with 500 or more. And here's 19th century right here. So the value that we're looking at is 6. But then we need to take 6 out of the total. You can set up a percent proportion here if you'd like. We're trying to find the percentage. So that's how we set it up, right? The part over the whole equals what we're trying to find over 100. That's the percentage side on the right. And what is our total? That's what we have to calculate. 2, 4, 10, 12, 24. We can do cross multiplication, which I'll go ahead and do. So it's 24x equals 600. We divide both sides by 24. I believe it's 25. Okay, let's just try it out anyway. 600. 24 goes in twice. 48. 12, 0, and 5 times 24 is 120. So, oh, wait a minute. This didn't, 500 or more pages. This answer's not up there, so I must have read this incorrectly. Let's try it again. So those books with 5 or more pages are from the 19th century. Let me read it one more time. Oh, oops, I added the total in there. So it's only supposed to be 12, 6 out of 12. You see this one? This shouldn't have been there. They could have put 25% in there and really tricked me. But they didn't. They were nice. So this is not accurate. Let's reset this. It should be 6 over 12, right? 2, 4, 10, 12 equals x over 100. But you can probably see that 6 out of 12 is just 50%. Yikes, that was scary, crazy. Let's see. That can happen. They were nice enough here not to give a tricky answer because I could have easily been incorrect. All right, let's go on to the next one here. But that's cool too. You do something. It's a big. Oh, and I got a comment from Black and Nightmare. Some more difficult and interesting logical questions. That's a valid point. I know some of these might seem easy. We're kind of going categorically through these problems. And what happens on Khan Academy is as you go through a set, sometimes the difficulty level can start to increase as we go further on. And so I'm kind of going through all these categories like the first time through, and then they start to get more challenging. Or maybe some of the other categories might be more challenging for you. You can check out some of my other videos from different topics in more advanced math concepts, and that might better suit your needs. But yes, I mean, it is a fair point. But unfortunately, I'm doing just this category today. But check out my archive of videos at YouTube. Go to YouTube, search for Scalar Learning, and you can check all that stuff out. All right, question number 2. We've got Guillermo asked the 10th and 11th graders at his school which sport they preferred between basketball and football. The table above displays a portion of the results. If 20% of the surveyed students who prefer football, it's 20% of the surveyed students who prefer football are in 10th grade. How many of the surveyed 11th graders at Guillermo's school prefer basketball? Okay, yikes, this is a lot of information. And how many of the surveyed 11th graders at Guillermo's school prefer basketball? Okay, so let's read it one more time. Let me just get my head wrapped around this. The table above displays a portion of the results, so only a portion. So 20% of the surveyed students who prefer football are in 10th grade. So 20% of this. Okay, so football, we've got 30. So what this means is 30 over the total number of people who play football. 30 is only 20%. Again, I'm setting up a percent proportion. So this is actually almost like percentage type problems, but we are using table data, but it's pretty heavy on the percentages. So 30 over x equals 20 over 100. We can cross multiply. We get 20x equals 3,000. Divide both sides by 20. Now you can do this mentally, and I'll show you a trick. 3,000 divided by 10 is 100. Therefore, 3,000 divided by 20, which is double 10, is half of 100, which is 50. So when you're dividing by something, you get an answer. If you double what you're dividing by, you half the final answer. So x equals 50. So that means, I'm sorry. 150, not 50, sorry. 150. Okay. So 30 out of 150. That means they are 120 11th graders that like football, right? 20% of the surveyed students who prefer football are in 10th grade. That means we can start to literally with just one value, I believe we can start to fill in this entire table almost. This total becomes 150. This total becomes 286, right? You see, I'm just adding this up. This one must be 120 plus something equals 166. Must be 44. I'm sorry, not 44. Excuse me, 46. Oh man, I'm making a lot of mistakes today. And then the 46 plus 130. I'm sorry. What plus 46 equals 36? This has got to be 90. And this has got to be 120. And look, everything matches up nicely. 120 plus 166, 286. This one adds up. This one adds up. These add up. These add up. All right, so it looks pretty good. Now it says, how many of the surveyed 11th graders preferred basketball? So it looks like we should have 46. And 46 is right here. If I've done all my calculations correctly, this should be good to go. And it was correct. So it's kind of it's a pretty lengthy problem. These are pretty lengthy problems. And I think we had a comment from one of the watchers on Instagram that these seem a little bit simple. And it's in terms of the level of math, like what is this? Maybe arguably pre-algebra, maybe algebra. Yes, but there's still a lot of calculations going on. I wouldn't call these, for me personally, I still think these can be tricky and you could make a mistake. So it's important to do these nice and methodically, carefully. Here we go. A science textbook has 4 chapters, each with a number of skills, problems, and of analysis problems here, right? Skills and analysis. Based on the table, which of the following statements is true? The relative frequency of analysis problems coming from chapter 4 is 4 out of 39. I'm going to disagree with this because it should be 4 over our total. Frequency would be the number that it actually occurs over the total number of questions. So I'm gonna cross this off. So we're gonna knock off 4 over 39. I don't think that's right. Relative frequency of analysis problems is 21 over 89. Where's my analysis? I see. Wait. Let me back up here. So the relative frequency of analysis problems coming from chapter 4. Relative frequency. Let me just read this a little more carefully, because what I think they're trying to say, it's a bit ambiguous, but they're saying the relative frequency of analysis problems coming from channel 4 is 4 out of 39. Now that total, there's a 39 total analysis problems. So that is true if they're saying the frequency of analysis problems, of all analysis problems. I kind of read it first initially as analysis problems out of just problems in chapter 4. So this actually, I might be going back and saying A might be okay, but let me look at chapter 2. It says, chapter 2, the relative frequency problems of analysis problems coming from chapter 2 is 21 out of 89. So we've got analysis problems isn't 21, it's 11. So hold on, let me just wait on A. Okay, I'm going to say okay for now. This is definitely wrong, because this would be total problems coming from chapter 2 would be 21 out of 89. So I'm going to knock that off. Frequency of problems in chapter 1 being skills problems. Problems. See, they changed the wording so subtly. Okay, the relative frequency of problems in chapter 1 being skills problems is 12 out of 23. Relative frequency of problems in chapter 1 being skills. Okay. So this would be right if they had 11 over 23, but they chose the value from analysis. The relative problems of frequency of problems in chapter 2 being skills is 2/3. 10 out of, no, this should be 10 out of 21. So it is A. Yeah, man, this wording is crazy. So 10 out of 21. So you see how subtle this is. And I'd say this is a hard problem, because you can misinterpret what's happening here and easily get it wrong, like I almost did. So I am going to go with A. And who knows, maybe I've still misinterpreted, but I think that's right now. Now I've understood the language. You can see that this test, so it is right. You can see that this test is becoming pretty heavy on the English, on being able to decode the English. God, a question like that, especially if English is your second language, I feel like would be very, very, you could be very prone to making a silly mistake on that one. And that's a decision that the College Board has made, to involve English a bit more, at least some of the nuances, and for better for worse. Victor decides to try 3 different routes to work for a period of 40 days. In the table above, he tracked whether he arrived to work late or on time each time that he used a particular route. According to the table, what is the probability that Victor was late given he used route A? So we know he used route A. Okay, so that's it. Route A. We're not worried about the 40 or anything. Probability that he arrived, what is the probability that he arrived late? Probability is the total on the bottom, total universe of outcomes. On the top is the ways we can win. Okay, that's it. We're going over this in my class right now. That's all probability is. And when I say win, we mean whatever they're asking for. Here, they're asking for the ways that what's the probability he'll be late? So how many times was he late? 6. What's the total times he took route A? 11. That's it. 6 11s. And it's D. So you can do that one pretty quickly. Let's take this guy. And let's go to the next one, the final one of the morning, a Friday morning. Let's go here. And let's do this. Like this. Question 5 of 5, enrollment trends in biologically focused programs. A biology professor is investigating trends in current enrollment of male-female undergraduate students in certain biologically focused cross-departmental programs. Trends of male. Okay. The above table represents the professor's findings. Note that students are not allowed to enroll in more than one of these programs at this particular school. Okay. So you can only enroll in bioinformatics, forensics, or pre-med. About how many female students should be enrolled in the forensics program to provide evidence that enrolling in forensics is independent of student gender. So this is almost like a full-on English question. You just got to decode what's going on. All right. So what are they saying? About how many female students should be enrolled in the forensics program to provide evidence that enrolling in forensics is independent of student gender. So this is barely a math question, in my opinion. If you're talking about forensics and you're talking about male, females, and you want to say that choosing forensics is independent of gender, that means gender shouldn't affect anything, which means that you shouldn't see a higher skewing of females to males in this class. So my assumption is we're basically going to want almost a 50-50 split. And I'm already looking at the answers. What I would say, I don't even see up there. What I would exactly say, I don't see up there. So let me make sure I'm understanding this correctly, because that's what I believe it's asking. I'm going to read it again from top to bottom. A biology professor, oh, and I see a comment from Spadis. Thank you. He says excellent. She says excellent. I appreciate that. Is investigating current trends of male-female undergraduate students in certain biologically focused cross-departmental programs. The above table represents the professor's findings. Note that students are not allowed to enroll in more than one of these programs at this particular school. About how many female students should be enrolled in the forensics program to provide evidence that enrolling in forensics is independent of student gender. So that's what I'm saying, 107, 107. And there is no 107. So see, this is why I'm wondering if I'm understanding it correctly. Like the closest answer is 118. And I'm really trying to think about this. So female students, and so 214 should be enrolled. But how many female students? Wouldn't it be 214, because then it'd be all female, no male. 210 would be kind of the same. 66. I'm going to go with 118. I want to read their explanation. I don't know why they don't put 107. And it does say about, so it's approximately. I don't know. All right, so it is right. Let's see their explanation. It says when two events are independent, the probability of one, it doesn't affect the other, right? Gender doesn't affect the enrollments. 214 were enrolled, and then a randomly selected student has approximately 31% probability of being enrolled in forensics, right? Let's say N forensics is students are female. We know that 381 of the students in the study are female. The ratio of N to 381 must approximately equal the probability already found. Oh, interesting. Interesting. So they are saying... Got it. Wow. So they did it differently to what I would, to my approach. They're basically taking the probability of being a student, period, in forensics, and see, oh, you know what? And I totally missed that. You know what? There's another way I did it incorrectly. I'm realizing, because I got the right answer almost by, I mean, it makes sense when you look at the totals, but look, this isn't correct to just say it should have been a 50-50 split. That's wrong, because there's not a 50-50 split of females to males. There's 381 to 310. There's more females than males, so there should be a slightly higher number of females than males. Another way to do this, so with that probability, another way to do this is, I mean, it's essentially the same thing, but you take 381 over 691, and you get the percentage of females, the decimal equivalent. And then you multiply that times 214, and that's exactly what they did here. Well, no, here they did it a little differently. But watch, you can get the same answer if you do 381 divided by 691. Let me try this here. Calculator. Whoops. So this is how I would have done it, I suppose. 381 divided by, what was it? 691. 691 equals this times 214 and 118, right? So you could do it that way too, where you're just basically matching up the percentages that are present in the total numbers. So man, I totally missed that. That was my bad. But hopefully that makes sense. The fact that you have to take that into consideration. And yeah, let me go back to my regular screen here. Undo share screen. All right, so that was everything for today. Thank you guys so much for joining. I hope that answered questions for you if you were watching and trying to solve the problems alongside with me. If you have any questions, you can always email me at huzaifa@scalarlearning.com. And please, if you want to see more videos like this, a math music video is coming out next week, and I'm so excited for special right triangles. If you want to see stuff like this be updated on everything, make sure to subscribe below to my channel and like this video if you like it, if you enjoy it. Put comments below, ask me questions. I want to answer your questions the best I can. So thank you guys so much. Have an amazing Friday. Take it easy.